Good morning, happy Monday morning. Hope we're all ready to get started with the week. Um, it is a brand new week, and we are continuing on the ecosystem project today. Hope you're all having a great day. Right, we're not using calories yet. Let's see what we've got running here. Right, so we have a random walker who's sort of wandering around. It's using acceleration and velocity, so it's got super smooth movement. Oh, that's my tea ready. And it looks like it can't go past the walls, so I think we successfully fixed that. Did we want to? I can't remember if we wanted to make it like wrap around the screen or not. Miguel, good morning. It's coming to the left to test the left. Oh no. Okay, fine. There, yeah. So looks like we're successfully constraining it. I guess the question is, do we want to continue constraining it, or do we want to try the wrapping thing, where we wrap it around? Um, I mean, I'm okay with either. I'm not really sure. We could always change this later. I don't really think it's gonna change the algorithms that we write very much. And eventually, we're gonna make this like much bigger. The other thing is that when it does go over the food like this, we want it to eat it. So we need to add that. So let's do that. I could leave this up and running so we can watch it wander around. All right, so we have our library, we have food. If we take a look at the library, we're bringing them in. So who's going to do the? I'm guessing the walker is going to check to see if it's eating the food. For right now, it's probably okay for us to loop through and do a bounding box check to see if like we're over the center of the food. I could also see that becoming a problem later, but then when it becomes a problem, we could potentially temporarily solve that with a thread. But then of course that will like itself become problems when we add too many threads. Let's maybe not worry about that right now, and we'll refactor later if we need to. I mean, isn't that kind of like the point of Rust, is making it easier for us to do that? So let's have our walker. Let's pass them all the food, and they can. Well, or should it be the game? The game tests, and it gets an object, so it gets a creature, and then it has the foods. So that would be here in the library. And then it will have a function that just runs and does the calculation. If it's eating it, then we just tell the walker, hey, you ate and you gain this many this size. And then this just goes away. I kind of like that. So our foods is a vector of random food. We do have a location, which is a point. And our random walker has location, which is a point. These are probably going to need to be public, but we'll handle that when we need to. So here in update, we're going to want to, well, so we just have an individual random walker right now, so it's not even a vector of walkers to run. So it's just an individual one. So we can write a new function in here. Function, like, is anything being eaten? Is eating? Do I care to update? Probably. Maybe I could just do like eating. So we'll have self. We also gonna want the specific creature in question. I know we have that here, but if we're eventually, like, we want to pass this in too. So this is going to probably be a mutable reference to the creature. Oh, because this is going to be different. So we don't know exactly what this is. Oh, so it's a type. So, that does change things, because I could create like in this case, it was going to have to be a generic to be able to handle all the different creatures that would eventually create. You know, it might just be better to actually to put this on the random walker and hand it all the foods and say, are you eating anything? Including other creatures eventually. So we'd have to mix the foods. Ooh, we'd have to just give two variables. One of the foods, one of the creatures. I kind of like that. So let's pivot. We'll go to the random walker. So function eat so we're going to mute self. We also need the foods. So this is a vector of food types. So that means use create food to pull that in. And it's actually a vec of food. We don't have any other creatures yet, so therefore it's just, that's all it's gonna check. And we're not gonna return anything. It's just gonna eat the thing and mutate. So it will like mutate the foods and it will mutate itself. So what we could do here is loop through each of the foods. So okay, so we'll give ourselves foods. What are you? Oh, yeah, so this is now a reference. We may have to dereference this. And then we want to see if the edge of our circle is over the center of the food. All right, so how can we do this? I'm thinking what we need to do is we need to get the distance, like the magnitude between two different points. So if I get a point, so if I create like a line, a vector that's essentially between the center and the edge. Oh no, it'll just be the center here. So the center of our of our location and the center of this location, then I can get the magnitude of that, and that will be the distance in pixels. And then I can check to see if that distance is less than the radius of our walker. And if it is, we're eating. Now, we do have the ability to get well, we can't get magnitudes with points, but this is something that I learned recently with N algebra, is that we can actually just skip all that and use the vector type. So I want to do this. So we're gonna use a vector 2, which has all these methods on it. So this is the thing. I don't know if you saw my tweet last night, but this is the thing I discovered yesterday, is that I should have been using vectors this entire time and then convert into points when I need to use it with GGEZ. Katali, good morning. So we want to now change all of these. So this is going to be a vector 2 for location. This is going to be a vector 2. In fact, velocity and acceleration can be a vector 2. So I'll just why do you change? Undo. Okay. Vector 2. I will still need a point 2 to convert back into for the draw. Actually, I don't have a draw in here, do I? Then in that case, I don't need this at all. All right, so we're going to create location, velocity, accelerations, vectors. We create our new vectors here. So everything is just like points. Oh no, here's their draw. So here's our problem, is that our circle, draw, mode, fill, we have to, for self.location, we have to point to from self.location. And then it just works because it's a two-dimensional vector and a two-dimensional point. Those are compatible. At least, oh no, yeah, I need to bring it in because I don't have point 2. There it goes. So that will allow us to still draw it out properly. And now, because these are, okay, so self-acceleration, so that this is going to be the same. So we're creating random for the X and a Y. But now we can, I believe we can change this to say self.velocity equals self.velocity plus self.acceleration. And no errors. So we get those, we get all the math that we wanted with points. We now get that with vectors. Super exciting. All right. So we can now update all of these things. It's going to be great. So update the velocity, update the location. What were we doing here? The location.x equals location.x. Oh, we're modulus arena width. This was our keeping it in the bounds. I don't know if I can do this with a single one. That would be more. That would be interesting. Let's see if we can. So if I take the X off. Yeah, okay. So not surprisingly, they haven't it didn't implement like modulus across a vector, which is not a standard mathematical practice anyways. So that's understood. Then we'll creep in the arena. So then this should be the same for right now because we're not doing anything on both. All right, so because of that, and now we need to do the same thing for food. We need to put you in, create a vector 2. Nope, not you. Okay. Want you. Are there any other point? Oh, there's just one point. Okay, so you're a vector 2. So you become a vector 2, and then in draw, you're going to be a point 2 from self-location. Okay. I want to make sure we didn't break it. And there we go. Everything's working exactly the way we wanted to, except now we get those mathematical operations, which, exactly what I wanted before. Changes everything. All right. So now I want to get the difference. Yeah, so much better. Okay, so now I want to get basically the line between these two. And the easiest way to do that is to just take the location of this one and the location of this one and subtract them from each other. So that's going to be the difference. The difference is it's like the direction and the distance all on the same thing. So I guess I'm going to call it the direction. So the direction is going to be the food dot location minus self dot location. I probably need to make this public. Yeah, okay, so food, you need to be public. All right, and now I want to get the magnitude of it. So let distance equals direction dot magnitude. And so what type is, it's an F32, perfect. So that's just distance in pixels. So now we can just say if distance is less than or equal to self dot size, that means we're overlapping the center of it. And that's I'm considering that eating. So a couple things here. First, we want to eat the food. So before, I'm guessing we'll mark the food as eaten. For right now, I can set this as false, but like, I should also add this, turn that on. I'm wondering, should I use an enum for the state of this, even if it's just two things? So it's just like food state, eaten true, eaten false. The main reason for that is I want to be able to remove it from the array, but I have to do that in the main library. So, oh, and this is going to be a Boolean. I don't set it here. So eaten Boolean here, eaten false. And we're going to now set you to food.eaten equals true. So we flip the switch. If you only have two values, it's better to use a Boolean instead. Okay, yeah, that makes sense. Okay, so we're setting it. We're setting it, telling the food that it's been eaten, and then we're also going to. Oh, so Rama, hey, good morning. Let's see. Food eaten. We mark that to be true. You know, other creatures could potentially, because I don't think I'm gonna go through the entire array of food and then move on. I can foresee a bug that if I then check like the next creature, it's gonna go through this food. I'm not gonna remove the item from the food until all the creatures have their eating. So I need to. Sorry, Ramahe, that is inappropriate. So I'm gonna do a temporary timeout. Let's not talk about those things. We'll keep it on food. The VS Code was fine. The other one was not. All right. Food eaten. Oh, so this also needs to be and food.eaten and not food.eaten. Okay. Then we're going to set it to be true. And we also need to grow ourselves. So we'll set self.size equals self.size plus food.calories. Let's see. Okay, food.eaten. So that's private and that's private. Okay, so eaten is private, calories there. And then finally, in the library, we need to remove it. So at the end of here, we can have just a function, so we don't do that all in here. Can't you remove the food on the eat function? So I don't think I can because the food is in the vector and I'm currently looping through the vector. I'm a little bit worried about mutating the vector itself and like removing it from there. Because if I remove it, then I guess like I'm used to loops like not handling that very well. Unless I'm like reversing loop, going from the end to the beginning, then I can like do something like that. I don't know. What are your guys' thoughts? I'm eagerly awaiting what I think you're saying, Miguel. Katali, you'd remove it in the loop. Okay, we could try it. Let's see how it handles. Now remove it in the loop. So we're gonna need to enumerate so we can get the ID. No, the index. So that's what we need. So in random walkers, so we're gonna need foods loop for food in foods. So we need to convert this into an. Yeah, I know. Doesn't it sound unsafe? Let's try it because I don't know what would happen, and I've not tried this in Rust. So let's what's the worst that can happen here? So we have to into Iterator, and then we can enumerate, and that will give us a tuple. Will you tell me index and value? So we're going to get index and food. So now, we don't need to check to see if the food has been eaten anymore because we're just going to remove it. So if we're eating it, we mark we don't even have to mark the food as eaten anymore. We just increase our size by the amount of calories that the food is, and then we remove this from the array. So I need, will this tell me? Slicing? No. Capacity guarantees. Oh man, I was really hoping there'd be a link to the documentation. Oh wait, here it is. Go ahead. Go ahead. Open that link. All right. No, it won't open the link. Let me see if I can just copy it. Oh my gosh. There. So it didn't like that. I think what I try to do is there's this weird thing that happens in it's not just VS Code. It's some of the other programs on Linux. Is it tries to open up like a browser, specifically Firefox, but not as its own browser here, but like inside of the other application. Which is, it's sort of like the phones, how they open up their own apps. All right, so let's take a look at Vector here. Oh, there's no dark mode. Do I have dark mode thing installed? No, I installed it on Firefox, but not this browser. So remove and return the element at position index within the vector, shifting all elements after it to the left. This is perfect. We just hand it an index. So remove. So then we're going to do foods dot remove index. What does that return? It returns just a type T. Cannot borrow foods as mutable more than once at a time. Ah, okay. So we have it mutable here. We're iterating through it. Oh, is it because we're in the iteration? Now, can I destructure it and then remove it? No. Left to the search box is a pencil button for dark mode. Oh, wait, left to the search box. Come on. There. Oh, perfect. Thank you. Thank you, DBC. Okay, so it won't let us do this because this is a double borrow. So we're borrowing once for this iteration. So we're handing it to the iterator as a borrow. And that's the protection here. It was a good idea, but I don't think we can do that here. Instead, what we're going to do is we're just going to mark them Eden. So we're going to do this again. So, and not. So I don't need. Ironically, I think, is the into iterator an ownership thing? I think that might be it. If I didn't do this to get the index, then I could probably remove it. I mean, I guess I could have a. I could have a function separately. Yeah, like I could set up queues. I can do other things to like maybe handle this, but it feels like it might be better just to remove item. I don't think I remove item. Nightly only. Removes the first instance of item if the vector exists. Try just iter. Well, so if I just do iter, I won't get the index of it. And dot iter, will it tell me if it's oh, this doesn't tell me if it's going to get owned. If I do iter, I won't get the index because I would need to enumerate. So I'm not sure what I would get from doing that. Right now I get the food item. I could. Oh, dot iter instead of into iterator. Which one did I do? Here, I could just undo it. Oh yeah, I did into iterator, didn't I? So let's try this. Dot iter. Yeah, no, I'm strict to make sure that like we're very like we're a good healthy community. All right, so we iterate, enumerate, but we're still. Yeah, so it's still borrowed. Now this is character. You know what? I could get a much better error message here if I just run this. And it'll tell me exactly what column it is. So yeah, it's this so we're borrowing here and then using the borrow here. Well, it depends, Ramahai. I would rather not focus, rather focus on coding and doing this and not like selling or bringing like attention to other things. But that's what the temporary band was for. Is uh, okay. So mutable borrow occurs here. Yeah. So even iter doesn't work with this. I might be able to have. Well, I mean, I could also set. No, I can make everything an option. All the foods being a vector be options, and then just set it to be none. That would remove it, and then at the end of the library, the update, I could remove all the things. I don't know if that makes like that doesn't feel right. I don't know. I'm feeling that maybe just marking it as eaten and then later on cleaning it all up at once at the end might be the best thing to do. Why is the first one immutable and the second one mutable? So they both say, oh, immutable borrow occurs here, immutable borrow, because it's borrowing it but only to read it, borrowing it only to read it. This is borrowing it to mutate it. You know, if it's immutable borrow, can I just give it a reference? Would that work? If I just say, hey, you just get a reference. Oh, okay. So iterator is not implemented for a reference to an iterator. Consider removing the reference. Okay, so yeah, it's Rust preventing me from doing anything silly. I think that's what we can put this down as is Rust doesn't want us to do this. And we can fight it and like come up with crazy cool ways of dealing with it by like using boxes. I don't really think we need to like set up an entire like system for handling multiple borrows. So we're gonna get direction if distance. Okay, so and not food dot eaten. Then we're gonna be food dot eaten equals true. So that sets you up. Now in update, we want to say I guess we're doing like a random walker update. I might want to change this to like move because that's kind of what this is doing. It's just moving. So let's say move. And then I can say self.randomWalker.eat, and we have to hand it self. Mutable reference to self.foods. Is that not? Oh. Move. Yeah. That's definitely move is a keyword. I've never used move. Let's see, move move myself. How about walk? And then eat is also private, so we'll come here. Okay, so that works for all of that. We're not using context. Interesting. And then the last thing I want to do here is now loop through all the foods and remove any of them that are that don't exist. So that's now function remove eaten foods. What would you think about creating like a foods structure and then a food structure, and then the food structure has all of the methods for like handling the eating of the foods and everything else like that. That might be one way to handle mutating the array within there, because I could maybe do it inside of there. I don't know. We might run into the same problem though. Okay, so mutable self, and I don't think we need anything else. We're not going to return anything. We're just going to say for food. Oh, here's where we're going to want to enumerate. So for index and food in self.foods.iter. The code would be more organized and clean if that works. Yeah, that is a big if though. Enumerate. So now we have our index and food. So if food.eaten, then I want to wait. This is going to be the same problem, isn't it? You know what? I can't do this here. I have to map it. Ooh, we have to map through this. This is into iterator. I want the vector. Do we implement? Where's map? Or is it like reduce? Like it's, I guess it wouldn't be map, it would be reduce. I could also index mute. Yeah, referring to, yeah, no, I get that. You know what? I realize I couldn't do this regardless of which way I would want to do that. So I'm realizing now that I'm gonna have to like do something like get a list of all of the indexes and then remove them all. I can actually do it the original way that we were thinking about doing that inside of the random walker eat function, but instead of just trying to do it inside of the array, I do it after the loop. So what I can say here is so we're going to need a vector of these arrays. So let eaten indexes, it's going to be a new empty vector. And then for each of these, so we are, so direction, so for index and food in foods dot iter enumerate. We don't need to check this anymore. So then we want to eaten indexes dot push the index. Then after this, Cannot borrow eaten indexes as mute. Oh, right. So you need to be mutable. Okay. And now I can loop through all of the eaten indexes and mutate. So now and this is where I think the foods structure would be nice, because I could say for index, I guess it's gonna be a food index in eaten indexes. We want to say foods dot remove food index. Okay, I realize there's another problem here. If I get like more than one, it might be the wrong index. That would be interesting and a little bit bad. I mean, so I can do this for right now, but because this shifts the array, it's not going to be very good for us. I need like a filter. Is there a filter? There's drain filter, which is nightly. Oh, so everything is just talking about drain filter here. What about drain? Creates a draining iterator that removes the specific range in the vector and yields the removed items. That's not exactly what I want either. Filters and iterator. Ooh, wait. Okay, so filters and iterator. So I need to be looking at iterators, or just like do a generic search for filter. An iterator that filters the elements of iter with predicate. This struct is created by the filter method on iterator. So let's go and actually take a look at it for real. Oh, okay. This is what I want. I mean, it's not perfect. Because it's still not going to be that like mutating, delete it one at a time. I'm still going to be marking them as eaten and then filter them all out later. There's a for each too. I don't think there's anything else that I could really deal with here. All right. Well, regardless, this means once again, I guess for right now, I'm gonna let the eaten one handle this, and we can just put this filter inside of here, and we'll not, and then we'll filter out after we eat. It's a mutation. I'm not super happy with it. I do think that a struct would be probably better. You can create a copy of the main vector to loop over that array and modify the original one. Modify the original one. I mean, ooh, interesting. Well, okay, so I could do that. So I can create, like, I could clone it. The indexes would still change. So I'd have to do enumerate backwards. Is there an iterator reverse? Because if there's an iterator reverse, then I could handle the indexes. Like an iterator left. Cloned and vec or so yes dot rev. Ooh, okay. Ooh, okay, that's interesting. So I could clone. I mean, let's try it. So I mean, this is not maybe the most efficient way space-wise to deal with this. Okay, so I want to let so the one we want. I guess I could just clone it here. So foods dot clone. So we're going to clone the foods. We're going to iterate it. Is it dot rev here, or is it dot rev off of the vector? No method name clone for food. Oh, I need to bring in the following trait bounds are not satisfied. I need to bring in clone. Like, is that all I, yeah, okay, so that, no. Yeah, no, so you're still not satisfied. Method clone exists, but the following trait bounds are not satisfied. Okay. Clone after iterator. Doesn't the borrow exist? Like, isn't that part of the problem? Is that I need to clone before a borrow? And so let's say I want to remove. Let's say just in here I just do a of course it's going to be happy with that. It's just not a good idea. You can go away too. Go away. Let's just say here that I want to do now foods dot remove of like 1 or maybe like 0. Yeah, so it's the same problem here. So the clone has to come before the iterator. Otherwise, it's just borrowing on that. Can I implement maybe there's a on vector there's like another clone. Create a variable for the clone? Well, I thought, I mean, yeah, we could try that. So vector, oh, I guess it's vec. Oh, is that what you're suggesting? Cloned instead of clone? Ah, okay. So let's try that. dot cloned. All right, what are you upset about? The trait standard clone is not implemented for food. And then reverse. Okay, so I'm going to need to reverse before this probably. Derive clone on a food struct, which of course I don't have a food struct right now, so we would need to create a food struct, derive clone on it. Blah. I mean, this all seems a lot of work in order to like do this here. I'm not really sure that this is like the appropriate place to do this. I'm thinking I need a food struct. I need a food struct, and then I can tell that struct. I can have it handle the eating. The food struct will take in. Well, the creature will look at that stuff. We hand it the foods. And then it says, I ate that food to the food struct. And then the struct mutates the original array. Or in this case, the vector. Now, can I derive clone not on the food struct, because this is just on this foods. I can't just do that to a vector, right? Derive a vector. Like derive what is it? Clone. Yeah, it's still not implemented for food. Do I need to pull in here? Oh, I didn't save. I don't think I need to pull in clone there. I'm just adding more errors and warnings. Yeah, this might need to be a architecture that I need to rethink, maybe off stream, sort of like give it some time to say like, okay, here's all the food. The food's wraps around food. It can have methods to manipulate its own vector and remove them. What I can do is do what we were thinking of doing before and just let MB derive on a food type. What's the MB? or maybe, that's maybe. Yeah. For some reason, I thought that was like a Rust command that was going to magically save everything for me. But no, alas. It's just normal English language. That is a loud car outside for this early in the morning. Okay, so I tried deriving on like the food vector, but I think because we don't have a food struct, we can't do this. So we can go down that path. The other thing that I can do is we could just do this normal. So let me see if I can get this working previously. We're going to enumerate. We're going to get the index. What are you now upset about? The 2 dots. We're going to eat this. Okay, so we're going to have let food. I guess this will be eaten foods. Eaten indexes. This will be a empty vector. Where's the food declaration? So in the library here, I am just creating the foods as a vector of foods and looping through all the foods to push them in. So it's not a structure on its own. I think the structure on its own would help me solve some of these problems. But before we go do that, I want to get this working here, and then maybe, oh, where is food? So food is here. Derive on that. So derive clone on here. And that would allow me to clone dot clones. Let's comment you out. Let's not remove. Oh, wait. Was it allowing me to do that? Foods dot remove index. No, okay. So it doesn't do that. The point of removing the foods from the vector is that you don't waste time in the loop checking for food that isn't there. And also it'll make the food dot instantly disappear. Yes, no, I do agree with that. So I don't have to do something like the if distance is less than this and it like doesn't exist. I understand about that. Although I could also just like grab these indexes here. But this is giving me specific items. Can I now clone not off of an iterator, but off of what dot clone? So now can I clone off of foods? Ooh, okay, so this works. This works. So then we want to reverse this. And so if distance is less than that, we will now remove the food. Remove the index. All right. No errors. 1 warning. What's you? Unused import. We don't need you anymore. All right. Let's try this out. I may have to like create a whole bunch more food so it has a bigger chance of actually running into them. Like just walk left. This is the problem about a random walker, is it has no desire to eat. So I wonder if I could just force this issue by creating a heck of a lot more foods. What would happen if I created 100 foods? They should... All right. Oh, come on. Move to the foods and eat them. Watch it carefully move between all the foods somehow. You're so close. That wasn't what I wanted to happen. It exploded. All right, we had an overflow. Let's see. Thread main panicked, assertion failed. Index is less than length. Oh, okay. So we removed something that is that was greater than the length there. I think we may have just run into where you don't want to mutate the array in here. We're trying to go in reverse. You're close to the screen. That was a bit of a jump scare. I know, it was like a little bit of, it was like an explosion. It just like, it grew a little bit and then just like ate everything really quickly. Now, is this like not happening? Reverses an iterator's direction. User iterators, after using reverse, an iterator will instead iterate from right to left. Okay, so this makes sense. That's exactly what I wanted to do. Maybe use reverse where you remove the... Well, so when I'm removing it, I just remove it from the index. So this should be like the index of like position index 99, then 98, 97, 96 as the index. And so if this distance is less than size, I guess, well, we saw that it didn't happen. The index are reversed too? But this is cloned, so this is the original one. You know what? That's a... It's interesting enough that I want to debug this. What is index? So we're gonna have another jump scare as soon as it hits this. Didn't go to the incomplete screen this time. So index. Interesting, okay. That was a lot of these that it hit really quickly. This that really didn't give me the information I wanted to give me. I'm thinking maybe instead of debug index here, I can debug index here, and it will let me know if the indexes are counting down or up. Oh yeah, and that's correct. It ate index 5 and it ate index 5 again, didn't it? And then 24, and then 95, then 4, and then 5 again after this. It didn't remove it. Oh, wait, you know what? Every time you remove, it shifts all the items in the array. So index 5 is not going to be the same as the previous index 5. So we can't necessarily use that to like verify. But if we're cloning, we have to make sure that this index is like in the direction that we think it is. So this needs to loop down. So like I want to see this like 99, 98, 97 and like looping down. I'm just going to run this for a second. This is counting up. I don't like that at all. Because that's not the actual index then. It's the index of the reversed array, of the reversed. The enumerate is not reversed. Wait, can I remove the, can I put the enumerate on the other side of the reverse? Yeah, I think you're right. The enumerate is not reversed. I don't think I can do this. Can I? All right. Oh, okay. So this is now counting down. This is more of what we want. So now when it runs into these, of course, none of the dots are near where our creature is. So that's cool. Hey, look at this. That might be, we may have a little bit too many calories in each of these. All right. So maybe we shouldn't have it so like growing so much. Okay, so that's good. So we've got the eat working now. How many calories is this? Calories is 10. That is way too much we've just learned. I'm thinking that we set you to calories 1. And then also for display, because that's like maybe too small to see, we could have the self.size is 3. Okay, I'm actually going to do this. Calories equals 1.0. And now I can say calories size is going to be calories times 3. So that will expend out, like the more calories it has, the bigger the food will look. You could subtract calories while moving. Ooh, that would be really interesting too. And that makes a lot of sense. I want to see how fast it grows with just 1. Because I get the fat. Oh, food, unexpected token. I missed a thing here. And .0. Okay, move left and eat that. Okay, so that's not too bad of like a growth. If I have like a whole bunch of food like this on here, then it can grow quite fast still. Yep. And what I could do is I could have it that every X ticks of the game, it adds another food for it to eat. So there's always food that it could eat. It just has to find it, which of course, this being a random walker, the chance of it finding it is really low. But I do like that idea of it subtracting calories also. So what if we do this? I'll leave you here so we can watch it. What if I kind of want to set, okay, do I have rand? I do have rand in here, don't I? No, not toml.json. Cargo toml. I do have rand. So in the food, let's bring in not that one. We'll bring in rand prelude. Wait, am I already? Oh, I'm already storing in RNG. Okay, so perfect. I don't have to bring you in. I'll say, look, here's thread RNG. So I can use this also. So calories, we can now set this to RNG.genRange between 0.1, so like really small, and maybe like 5.0, which is really large. I probably only want to like double this in size now because this is either going to be like really tiny dots or like really large. And now, okay, so there's that. Let's run you. Here's all of our food. The sizes are now based upon how nutritious they are. And you only have to overlap the center of the food to eat it. Nope. And then in the random walker, under walk, we have our size here. We can reduce our size by 1. Scars, am I gonna have this code public? Yes, I do have the code public. I don't have a bot to make it easy to like sort of see that, so I understand like not being able to find that. But yeah, no, I'm perfectly fine with you asking, you or anybody else asking that. So always feel free to ask. So when I walk, I want to keep in the arena, and then I want to self dot size. What's our rate of decay here? I don't think I should just like -1 because there's a lot of frames really quickly. No, okay, so that's not random walk GGZ. It's actually nature of code. Nature of code in Rust under Brooks builds, and then I'm in the ecosystem directory for that. Subset size equals, what if I do minus like 0.01? This might, so it's just an arbitrary magic number. I'm not super happy with that. We might be able to figure out something better. What about subtracting based on the size? So like the larger How did I get an equals in there? I misclicked. It's like the larger it is, the faster it loses size. Oh yeah, so this guy's gonna die before it even gets to food. Yeah, look at it, it's shrinking. And it's gone. Oh, that's hilarious. It's in a negative now because it's a float. So I would want to do something where as it when it gets when it gets to 0 it okay, so that's maybe shrinking a little bit too much. I do like the idea of like a minimum size. Just eat a little bit before you die. Oh. Okay, you went after like the least nutritious food you could have gotten after. And it fades away. All right. So yes, that's not working. I will get you, Skarsh, the location. I should update. You know what? I think I haven't updated my my information properly. Oh, I can make it faster if it's smaller. There's all sorts of things that we can do with this. Definitely. So we are can eat food and shrinks when walking. Is there a README on this? I don't have a README. Okay, so to do okay, so we want to limit how small a well, do I want to limit? I think it can die if it just doesn't if it doesn't get anything. So kill the walker if it runs out of energy. So that will just like remove it completely. So I want that to be in a vector then. So that means we're gonna have to play with generics. So that'll be fun. I can potentially make it faster if smaller. I mean, we could potentially do that. We could also like make it increase the speed, but that increases the energy consumption too. That could be really interesting as well. So it could jump around, give them like special abilities like teleport, but it makes it like use up special energy. I'm not gonna worry about that right now. It's like kill the walker if it runs out of energy. And start with less food, but add food every X ticks. So I don't know exactly what I want like what I want that to be, and I want to use delta time. That will help scale things properly. Make the energy consumption scalable. The bigger it gets, the more energy it uses. That's an interesting idea too. So many interesting possibilities. Maybe to do like think about it. So, you know what? Do I want to do this like scalable energy usage based on size? Move faster as smaller. I'm going to say that this is Katali, you are Crossbow. All right, so I'm going to commit this. This is going to be what is left to do for chapter 1. And I'm going to push this up. So I'm going to go find this and give you guys the link specifically for you, Skarsh. So this is github.com. I recently created this, and I guess I didn't update my link down below. I do have Brooks Patton, but I also created a Brooks builds. And that is where I have Nature of Code and Rust. I also need now to go to my Twitch. And there is a link to the code. If you have any ideas that I didn't write down, please feel free to open a pull request or an issue. You can open a pull request directly to the README to like add those ideas in, or an issue. Also, if I have any bugs or anything else, feel free to open up a pull request in any of my code. Like the worst that can happen is I just decide that I'm going to implement it like on stream. But I really want to sort of like develop the community of this all learning and coding together. To make the project more complete, create different types of food in the years. Yes, that is definitely going to happen. So I didn't really explain what I'm doing, and I've got 2 minutes left, so let's do that right now. So I am going through the book Nature of Code by Dan Schiffman. He's also the person behind the Coding Train YouTube channel. One of the reasons I'm using this book, which I actually do, I do own a physical copy of this book, is you can read it for free online. So if you want to follow along, you don't want to buy the book, you can read everything. We're currently on chapter 1. We're at the very end. So we're on this ecosystem project. So my idea is that at the end of every chapter, there's this, you update the ecosystem project. So I'm going to update with something that I learned within there. So we'll create a new walker, a new type of walker for each of these. And who knows, maybe I'll do something like for every, like I'll start with like multiple of each types of walker. And it's going to be like sort of our unique game of life, essentially. And they can eat each other, everything will be fine. With, of course, by the end, we're getting to neural networks, so we'll have very dumb walkers and very, 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 very smart walkers, theoretically. All right, well, with that being said, I think I've got everything sort of set up. I've got the link to the code out. If you're watching the VOD, I'm also going to put the link to the code in the description to the VOD, or on YouTube in the description of the YouTube. I don't think I have anything else. I'm streaming on Mondays, Wednesdays, and Fridays at 6:45 a.m. Mountain Time. So I'll see you on Wednesday. Yes, look forward to it, Katali. And I will switch over to my ending screen. I do have a day job, so I've got to go do some programming for the day. And I'll see you around. Have a good one.